All right, B and Alex, welcome to day 3. It is now Wednesday. We are still talking about antiderivatives and indefinite integration. We're basically about done here. We're going to do something a little bit different tomorrow. We're going to use this for area, and that'll set up what we're going to do moving forward. So this is the last set of stuff that I've got for you. So I've got 3 formulas for you today, and then we're going to work through a couple examples down here of how you can use them. So the first one is the integral of e to the x dx. If you think back of what the derivative of e to the x is, it is e to the x. Okay, so this is a very, very basic one. So it would make sense that the integral of e to the x would also be e to the x, and can't forget about our plus c. So that'll come up. If there's a number in front, just isolate it like we did on Monday, where you can take the whole number and put it out in front. So you should be good to go on that, and it should be fine. For instance, like if you've got the integral of 4e to the x dx, the 4 really just rides out front. You got e to the x dx, and then it turns into 4e to the x again. Okay, so that's what that integral would be. So second formula that we got is the integral of something other than e to the x. So let's say a to the x dx. So this could be any number. Okay, a could be any number. The way we derive that is we turn it into 1 over the natural log of a, and then we have to multiply by the original. So multiply by a to the x. So you can put that on top if you really want, or you can just write it next to it. Third one that we've got is the the integral of 1 over x. Okay, this actually came up in that example 3 that I did on Monday when I didn't realize it was going to be in there, and just kind of X'd it out and left it out for the time being. This is when we're picking that back up. Okay, so the integral of 1 over x is the natural log of the absolute value of x. Okay, so you'll see this in just a second when we get to use it. So these are the last 3 formulas of the antiderivatives for now. We'll be moving into using it a little bit tomorrow, and then getting better with our skill as we go through here into next week. Okay, so let's take a look at example 1. So from Monday's work, we know that we're allowed to split these, and they can have their own integral. So we can do the integral of 5x, and then we can do the integral of 3 to the x. I'm not bringing the dx's down because it's not really important to us. We just know that we need to put a plus c after it. So dx is just there for to make it proper. Okay, so I'm going to derive 5x. Now, I can use another rule from Monday, the one that I just mentioned a little bit ago with this 4e to the x up here. Okay, so I can relocate 5 out in front of the integral, and then just leave an x in there. Okay, and it's very easy to integrate x because all you have to do is add 1 to the exponent and then divide by that number. So we're undoing it. So basically think of what would the original had to been in order to derive it to get x. So the way it works, add 1 to the exponent. Remember, this is what we did Monday, and divide by 2. So I've still got this 5 out front. I'll just multiply by it here, and then we'll make it look right here in just a second. Now I've got to work on this 3 to the x over here. Okay, this directly applies to the second formula that we learned today. This is like saying a to the x. So it's very, very simple in order to just put in 3 where a would be. So I'm going to have 1 over the natural log of 3, and then I have to multiply by 3 to the x. And I'll put in my plus c here in just a few minutes. All right, so this would be the same thing down here. 1 over natural log of 3 times 3, not 3x, 3 to the x. Okay, so let's make this look right, because right now it looks pretty silly. If I was going to write out that first part, I would probably go with 5/2 x squared. That's going to make us look best here. Okay, we're going to put equals because this is what our integral actually is. Over here on this next part, there's not a great way of going at it, but I'm a big fan of doing this. 3 to the x over natural log of 3. A lot of people don't like writing it that way. They like to write it separate, but I think this is great for simplicity. Don't forget to put your plus c, and we're out of here. That example's done. Okay, let's move over to example 2, and we'll be just about done here today. So this is another example where you have to simplify before you start. Okay, so we don't know how to do this. We don't have any kind of quotient rule for integrals right now, and this is our best shot at this point. So what I'm going to do moving forward is before everything gets its own integral, I'm just going to give everything its own base. So x cubed is getting its own x cubed. 2x squared is going to get its own x cubed. And 1 is going to get its own x cubed. And I'm going to start reducing the powers. I'm also going to do that as I give them all their own integral. So this first one, if I give it its own integral, x cubed over x cubed is 1. Okay, so we can take care of that relatively quickly here in a few minutes. I'm going to do another integral here. I've got 2 x's on top and 1 on the bottom, so the 2 on top are going to cancel and 2 of them on the bottom will cancel. So this is just going to leave me with 2 over x. This is going to apply for our third rule that we learned today. That's up here in the top left where the little red refresh looking button is. Okay. And then lastly, I've got this minus and 1 over x cubed. I don't think we're going to be able to do that like it sits, so we may have to change it around. If you want to go ahead and change it around right now, I will. All I'm going to do is bring the x cubed to the top. Okay, so it was 1 over x cubed, as you can see right above it. This would really end up being x to the negative third. Now let's talk for just a second why this right here doesn't work like that. Okay, so if I wanted to bring that x to the top, it would be 2x to the negative first. And then I go to integrating that, and I add 1 to the exponent and then divide by that. I've got 2x to the 0 over 0. And we all know that that's not true. Okay, so that's why it has its own special rule. And that's why we didn't finish it on Monday whenever we were working on that. So let's start integrating. I've got 1. That applies to our our second rule that we learned on Monday, where you just have a whole number, a constant, and really all that has to happen is you have to add an x to it. So it would be 1x, but nobody's going to write the 1 with it. It's just going to be x. Okay. Next part, we have 2 over x. Now let me show you what this actually is. This, let me box it in. I'm going to bring it over here. This is really 2 times the integral of 1 over x. Okay, because 2 over x is 2 over 1 times 1 over x. Okay, so that's how we can separate 2 and 1 over x. So if you really want to look at it like this, it makes your life a lot easier. Okay, the 2 is just going to write out in front, and then we just take the integral of 1 over x, which we know is the natural log of x. So if 2 is riding in front, and then the integral of 1 over x is natural log of the absolute value of x, we're set. Okay, so we've got that one done. And then our last one over here, I've got to do x to the negative third. I'm just going to add 1 to the exponent and then divide by it. So adding 1 to the exponent would be x to the negative second, and then we'll divide by negative 2. We can make it look better because I got a negative divided by a negative. So x is still good. 2 natural log of x is still good. And then minus and minus is going to end up being a plus. I'm going to go with 1 over 2x squared. I'm going to send that x back to the bottom and make the power positive. So I feel like this is our best option for making this look like this. So 1 over x is actually going to come up a lot in the second half of calculus here. It's a common thing that we run into, and we'll just be represented as natural log of x. Okay, so I hope this went well for you. I'm going to zoom it back out here in case you need to see everything together. We got the last set of problems today will be page 287, and you're doing 29 through 32. So that's the end of that section that we've been working on this week. So like I said, I got one more section with you tomorrow. We're going to be talking about area, and then we'll do that celebration on Friday, and then get started up with definite integrals. They don't really call them definite integrals, but we'll get started back up with those on Monday. Okay, so let me know if you got any questions, and